muttering, and we'll get started shortly. If folks haven't signed in yet, this is a great time to do that. And I think, is there anyone who still needs to sign in? If you want to raise your hand. Someone from our node, would you mind just making sure folks have the sign-on sheet? Thank you, and we will start shortly.
He needs it up there?
Yeah, he does.
Anyway, welcome all to our presentation by Vermont and the Unitarian Church Climate Action Team. We also have a co-sponsor of Renewable Energy Vermont, helped out a little bit with it as well. So here's a little bit of housekeeping here. Take care of yourself. Bathrooms are downstairs. There's 3 of them. And let us know, please, if you don't want your photo taken. We're going to have a couple of people taking pictures, but just cover your face if you see somebody with a camera. Do whatever you like. Take care of yourself. Right. Right. And if there's any other accessibility needs, see one of the staff around here and we'll see if we can help you out with it. And we have some next step sheets that you can write questions on. You look in your pew, I think there's little cards or papers there that Casey distributed. So help us out, and after Roger's presentation, we're going to field a few of the questions for you. 350 Vermont is building a people-powered and people-led climate justice movement in Vermont for a just and thriving world. So we're guided by, as you may know, Bill McKibben, a Vermonter from Ripton, was the originator of 350, and it means 350 particles per million of CO2, and we are now at 400 and something, so we need to be conscious of that and where our heritage came from. And we're building collective power for climate justice. This is the Montpelier node of 350 Vermont. You'll see some of the characters in the picture here. And glad to have you here. We were, years ago, the pandemic shut down for a while, and now we're back and active. And we've been sponsoring this summer climate study series, and this is an encore presentation with Roger tonight. Agenda is Roger will speak in just a minute or two, and after that we're going to process a little bit, talk about what we can do, next steps for action, closing, and then we would really like you to stay later, and we're going to have refreshments and one-on-one conversations, extra questions for Roger downstairs in the vestry. So welcome, and I'm going to turn it over to Casey.
Wow, there's a lot of people here that give a darn. Good evening, my name's Casey Whiteley, and I want to welcome each and every one of you here to the Unitarian Church in Montpelier, who's been generous enough to host our summer series and host Roger Hill tonight. The Unitarian Church has a strong commitment to climate and social justice. We're meeting here on the traditional lands of the Abenaki Nation. And the Western Abenaki are the traditional caretakers of these Vermont lands and waters, which they call Endakina, meaning homeland. Hope you'll join me in acknowledging and honoring with gratitude the land, the rivers, the water, mountains, the fields, the Abenaki community, elders, both past and present, and future generations. We're committed to continuing to learn to care for the land, the waters, and the air here in partnership with the Abenaki people. Thanks.
Hi, everyone. Oops. There's like a stool here. Sorry. Roger doesn't need it, and I don't need it either. I'm Andrea Stander. I am a member of the Montpelier Node, former member of the board of 350 Vermont. Thank you all so much for coming out tonight. We also have an audience who is joining us through the live stream, and this presentation will be recorded and will be available through Orca. And big thanks to Orca for making this possible. So I feel very honored that I'm going to be introducing our speaker tonight. Most of you know him. Roger Hill has been in meteorology for 50 years, and you can just think for a moment about how much meteorology has changed in 50 years, and he's seen all of those changes. He also served in the Army. He worked for the National Weather Service all over the country. He also worked extensively with various utility companies here in Vermont. And then the place where most people know him from is he was the weatherman for WDEV for 25 years or so. And I think a lot of people planned their day based on Roger's forecast. So he's now retired, but he's still forecasting. And we're very grateful that he was able to come and do this for us tonight. And Roger assured us that this will be a no punches pulled presentation. So some of it will be challenging. But he also reminded me that knowledge is power, and we're going to need power. Please welcome Roger Hill.
I'm going to get my up here, and thank you very much, Andrea. Appreciate that.
You want this back, Roger?
No, I think we're good. I think we're going to be good here. So here, just expand. Okay. Yeah. What's going on here? Oh, come on. There it is. Okay. Okay. Just expand that. I'm not seeing my notes though. Oh, go to. Hold on a second. There we go. Okay. All right. If I don't have my notes, it's not going to go well. All right. First of all, I'm going to adjust this so I don't begin. I have a kind of a booming voice, so it's going to get a little bit loud here for some. But so thank you very much for attending this climate talk. What I'm going to do is I'm going to cover a number of different things. I'm going to start in with James Hansen, who started back in, I believe it was about 1988 or 87. And is it good?
It needs to be right opposite your mouth.
Very good, very good. And about 87, we had James Hansen give testimony in Congress and talking about carbon dioxide in the atmosphere and what it was doing to the planet, and it was heating the planet. And of course, some of the fossil fuel utilities knew that we had ongoing emissions and what the reaction of that extra carbon in the atmosphere was going to do, and that goes back quite a few number of years, I think even into the 70s. So it's well known that, in long story short, the atmosphere is heated by the sun, And when you have carbon dioxide, the molecules kind of dance around a little bit and generate heat. And that heating occurs. And this is kind of what the name of the game is here. So I'm going to get a little bit into James Hansen and focusing in on a more rapid kind of global temperature rise and projection and why. Does sulfur dioxide or SO2 emissions pollution mask a more rapid warming? And we're finding that is definitely happening. Human infrastructure and impacts globally, and then we're going to kind of go into the national level and then locally. And kind of from a Homeland Security perspective, I incorporated a fantastic presentation that was given by Sunny Westcott. She is the Chief Meteorologist of Homeland Security. Now, unless you're in kind of the emergency management and utilities and this kind of thing, you're not going to hear about her too much. But she's the only meteorologist employed, and boy, oh boy, does she have some great research and some great stuff. So I borrowed quite a bit of her slides. But the slides have a lot of writing on it, so we're going to go through some of that, and it'll be a little bit slower here, but I have about 45 minutes to speak, and then we'll have some questions after that. Human infrastructure impacts, as I mentioned, globally, kind of the big picture, and then nationally, and then kind of drilling on down into Vermont, and that's what kind of gets very interesting. And all of us know the flooding that has occurred recently. Well, that's changed up a lot of statistics. We'll get into that in a second as we take that deeper dive into the Green Mountain State and the future. I'm also going to touch on the lack of political leadership and electing leaders who really have no intention of ever actually leading, at least on this issue, maybe some other issues, but we'll cover a little bit of that as well. And I'm just going to speak forthright. I think our elected leaders, I know there's a lot of good things people know about, but are they really, really serious in tackling what we really need to do? And from my perspective, and from what you're going to see here, I don't think so. I don't think we have leadership. I think we have people who placehold. They get elected to do basically nothing and keep taxes low. I know taxes are really high, but we're going to have governing, and governing is what the future is going to need, and of course now with the elections, that's changed up quite a bit as well. So we have the classic Faustian bargain, and Faustian bargain is a deal where a person gives up something of great moral value in exchange for a material benefit. And we've been drilling oil and digging up coal and then burning it for heating and whatnot. It's served us very, very well, but we're getting that material benefit. The Faustian bargain, the term comes from the legend Faust, a German magician who sold his soul to the devil for the knowledge of power. In most versions of the world of the story, Faust receives his powers for 24 years, but is eternally damned. And the hope is that we are not eternally damned. Well, we might be. I know that I'm in a church here, but I'm dealing with evidence. And I really thank you very much, Unitarian Universalist Church, for allowing me to do this. But I just want to mention that we're looking at evidence-based data here, and this is what I deal with. So just want to also let you know that if you are sensitive and emotionally distraught and want to leave at any time, I will not hold it against anybody. So the NASA Goddard Institute for Space Studies, or JISS as we call it, the temperature plot, and this is from what James Hansen uses. And I would ask that you study this with me for a little bit here and kind of focus in. What you're looking at is you're seeing these sort of minor ups and downs in the blue, and then those we'll get into the black squares, and the whole realm of what you're looking at here. And you can see that back in 1880 on the left-hand side, and then here to the latest is about 2023, 2024, early 2024, I believe. And that is the last bit of data that we're seeing here. But I would just ask that you study this with me for a little bit. Minor ups and downs, but the general trend, of course, is warming. Note we have had the 12-month running mean, that's in the blue line there. A long-running mean for 132 months is in red, and then the best linear fit is in green. Kind of keeping these in mind, all show temperature trends are going up, but interwoven in this are the period from January through December, and these are those black boxes that shows what is the mean temperature. Also shows the natural variations of El Nino, the warm phase, and the super El Nino spikes, and this, of course, is sea surface temperatures that are off in the subtropics or the tropics, and El Nino being the warm phase, La Nina, which is what we currently have ongoing right now, is the cold phase. But we just came out of an El Nino spike, and now we're into that cooler phase, this having occurred this summer and going into this winter. That is the La Nina. These are all natural occurrences. This has been going on for millennia, so we're going to dive in a little bit closer on that as well. So note the acceleration in temperatures which begin about 2010. So 2010 being on the right-hand side there, you see 2000 and 2020, so that's that middle line, just about just below the O of Niños, and you can see that at roughly about 2010, that's where the 132 monthly mean in red left the general trend of temperature going up, which is about 1.8 degrees Celsius rise in temperature per decade. So per every 10 years, we were seeing almost 0.2 of a degree of Celsius temperature. A lot of debate has ensued as to what caused the trend to increase. And note the red line. You can see that red line suddenly departs and starts to accelerate a little bit more warmer. Hansen has explored the potential causes of this change of faster warming. In his findings, the reduction of the sulfur pollution, or SO2, sulfur dioxide, from shipping also reduced the aerosols that it produced. And this has led to more sunshine in portions of the oceans, and this has caused them to anomalously heat up. And the latest information, it's still a little bit debatable, but this sort of trajectory, as you see, that goes into the yellow there, well, that faster warming has been because we have been sort of masking what we already have in terms of carbon dioxide, that extra carbon dioxide which we're continually emitting into the atmosphere, much more than 350 parts per million, which is what 350 Vermont's about. We're about 420, 421, last I checked, and we're just adding more carbon into the atmosphere. Of course, there's CH4, which is methane, and other global greenhouse gases that are also being emitted, and also through land use is an issue as well. But all of these things combined. But just note that the El Nino, that natural variation, sort of with that warming background, that boost occurred last year, 2023 to 2024, during the winter. And then that 12-month running mean, that running average temperature high, essentially the natural variations in temperature with background warming. But interestingly, something happened about 2010, and we're going to explore that here. So what has happened is the sulfur dioxide emissions, SO2, is considered, of course, unhealthy. It's a bad thing to breathe in. It can irritate the respiratory system, causing coughing, wheezing, breathing difficulties, especially for people with asthma, and particularly harmful when inhaled at high concentrations. The exposure to SO2 can cause and aggravate existing lung conditions, for example, like bronchitis, and contribute to cardiovascular issues. SO2 emissions shown before the sulfur reductions took place. You can see where the SO2 emissions clearly come from, basically along the shipping lanes. And so you see all those little lines there. These are where the ships are going along that same general path. And you can see that it has an effect. But with the SO2 emissions from those ships, James Hansen's catch is an interesting point to keep in mind about this whole particular extra pollution. And then all of a sudden, we did some good things about it. So maritime shipping has significantly reduced its sulfur dioxide load, SO2 emissions, and due to new regulations implemented by the International Maritime Organization, or the IMO, in about 2020, and a little bit before that, kind of leading up into that, which mandated a drastic decrease in the allowed sulfur content of ship fuel. This resulted in approximately an 80% reduction in the SO2 emissions globally. This change aimed to improve air quality, but also may have inadvertently contributed to the increase in global warming by reducing the cooling effects of sulfate aerosols from ship exhaust. So it's one of these things, we tried to do something good. Little did we know, it was masking the extra heat in the atmosphere, and then you add more sunshine that has warmed the oceans. As the oceans warm, suddenly you get extra warming in the atmosphere, and that's the way it's been going along for the most part with overheating of the planet. So basically, in essence, the International Maritime Organization, stricter regulations for large ships have led to an 8.5 metric megaton reduction in the annual sulfur dioxide emissions. By eliminating this mask of pollution, inadvertent warming has been theorized, but at this time it was not widely agreed upon by all climate science community, but it is sort of coming online. And this is generally more associated with James Hansen's findings, and I believe that this is what we're finding out. But we will know more about this sort of a causal relationship, if you will, in the next coming years, couple years basically. The rate of warming suddenly increased from about 2015 and after a little bit after 2010 or whatever, and the rate of warming suddenly increased by 2015, and it is believed to be a direct effect of more sunshine, again, over the ocean shipping lanes due to less filtering of the particulate matter aloft. And this produces basically low cloud formation when you have this extra pollution in the atmosphere, and those low clouds, of course, cause a cooling effect on the ocean. So consequently, that reduction in sulfur has led to this jump in rising temperature trends, and that can be seen in the yellow with that projection going upward. So once again, good intentions reduce that pollution, and lo and behold, we have an increase in warming. The more rapid warming has been detected in the surface sea temperature anomalies, or the anomaly especially across the North Atlantic and the North Pacific. You can see the sort of tan colors there. That is where the warming is taking place. The cooler areas in this particular map on the left there, you can see where that's a little bit cooler. But notice it's a little bit more centered in the northern hemisphere than the southern hemisphere. And so consequently, this more immediate rise has long-term detrimental impacts to the world's oceans, flora, and fauna, and we were entering a more rapid mass extinction worldwide. So lots and lots of trouble ahead. I will now focus a little bit more on the different angle and what will drive and potentially kill us off the planet as we focus now on extreme weather. This is part of Sunny Westcott's PowerPoint, so I'm using a lot of her stuff here, and her focus is weather hazards. When I was working for the utilities, Velco, and essentially all the utilities under Velco, basically what we've seen is an increasing trend in severe weather, and I think people can acknowledge here that we've seen more and more of this wicked weather whiplash kind of thing going on, and we're going to get a little bit more into that. But these extreme weather events are on the rise in frequency and also in intensity. Our critical infrastructure is affected in many ways. All hazards will be worsening in the coming years ahead. In my humble opinion, recently chosen leaders of government do not lead and have won elections on not leading and tend to not solve the problem. This is their intention on the federal side and even in the state. And others then just sort of tampering around the edges and saying we're trying to do something. Now, most folks think it's just costs too much for the taxpayers. To me, it appears to me that we pay taxes to our government for not doing anything about the future calamities ahead, and that's a bad situation. There will be a breaking point. Mother Nature is pissed off, and humanity is slow to act. So, in a nutshell, deeper areas of low pressure produce stronger storm systems, rapidly developing storm systems with extra water vapor and an overheating planet. Warmer oceans and odd, large-scale, high-amplitude configurations of the jet stream will cause more severe property damage and fatalities ahead. let me explain. It's a little too hard to read, so I will list them out. But these are some of the effects of just what a deeper area of low pressure does. So we have the slower moving, more mature storm systems. That's what develops. In fact, there's one of them out to the southwest that's covering a good section of the country as we speak. Also, we're seeing a warming of 1 degree Celsius, means about 7% more water vapor, and this is fueling more these storms and producing much more heavier precipitation. And I think Montpelier, Worcester, Plainfield, Lyndonville, etc. know a lot about that. We're looking at the warm season. We're seeing flash floods, where we're seeing a month's worth of rain in less than 12 hours. Stronger tropical cyclones further north, further inland. Take last Helene we've seen, that affected western North Carolina, and also even Irene. And you could throw in Sandy, and there's been quite a few others in the recent past. Sediment flows threaten water supplies and public safety. Prolonged periods of between weather events. We're seeing this, experienced this very recently. We've had a tremendous fall, right? Everybody would agree. In fact, I've never seen so much sunshine. I've never seen so many areas of higher pressure land right over the Northeast in New England. It's just very odd. It is a very oddball kind of situation because typically November is our cloudiest month followed by December. Well, we're starting to get into more clouds as we get into next week, for example, but it has been an oddball kind of situation here. I'm going to drink real quick. So I talked about the sediment flows, prolonged periods between weather systems, weather events, experiencing this even up to today, for example, and then higher heat and direct sunlight between storm systems, that has an effect on us. Increased evaporation and transpiration, which is like where the leaves and the grasses and whatnot emit moisture and try to cool the planet a little bit. We're seeing also more humidity in the air, etc. But also a very much of a quickening of the hydrologic cycle. So examples include increased flash flooding, which everyone can see, and we all know about it here in Vermont. We're seeing the rising temperatures in northern climates during the wintertime that affect, wintertime that most folks do not keep track of. And one of these little smaller sort of subset details besides the big sort of sexy big storms and floods that we know about and the high river water, etc., is if you just drill down, for example, is we have sort of a quickening of the freeze-thaw cycle is increasing each winter. We're seeing much more thaws during the wintertime because the temperature's a little warmer, so we're going above 32, below 32, whatnot. What does this do? Well, this causes problems. We have more rainfall, less snowfall, and that less snow cover, this increases the breakup of asphalt and it causes potholes as one example. So this is another aspect of climate change, global warming. The same freeze-thaw also produces higher incidence of landslides. We've had a landslide here in Montpelier. That's definitely freeze-thaw, 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 rocks expand, crack, break off, landslide, boom. So this is not your grandparents' climate anymore, but our aging infrastructure is our grandparents' infrastructure. So this graph here shows you the annual temperature trends compared to the 20th century average. The upper left side there shows the first 30 years of baseline, and the last century shows the warming trends. So you can see with the blue being the colder temperatures and the red being the warmer temperatures, the more anomalous temperatures, we have warmed out of the Holocene period and into the Anthropocene. The Anthropocene means anthropogenic, that means us, human-caused. This is the average temperature trends from 1895 through 2020. Note the average temperature trends were going up, but also note an absence of temperature rising in these rises in the central states. You can see that from like eastern Texas, Oklahoma, all the way to Tennessee, Kentucky, and then all the way to sort of South Carolina. Well, interestingly, the same issue with our sulfur dioxide in the oceans and those ships putting those plumes out and then causing a little filtering of that sunlight, et cetera, and then having that reduction. I think their coal-fired power plants are also sort of masking what is hidden right now in terms of what they're seeing in the south central U.S. This is my anecdotally information based on what I'm seeing from Hansen. It would not be surprising to see, well, why is it that the temperatures have not risen in the same areas that have the areas of the most climate deniers? You might want to note that as well. And so what is the oddity to that? Well, they still have a lot of pollution in those particular parts of the country, and that could be masking the temperature. If we start to improve the air quality in the south central states and not have coal-fired power plants and those cancer zones that we hear about and whatnot in Louisiana and this and that, it could be that those temperatures make a big, big jump, just like the ocean did. This is just my conjecture, but this kind of just shows how fragile and sensitive the atmosphere is. Again, it's my hunch. It turns out to be true. This opens up a new can of worms for the Climate Connection and its ever-crazy politics of the area. Okay, we talked temperature. Now we're going to go to moisture, precipitation. So what we're looking at is the same kind of deal here from 1901 to 1930 on the far left, and then finally ending 1991 into around 2020. Precipitation patterns have been shifting geographically and also on some monthly time scales. Note the general trends. Each 1 degree Celsius of warming brings about 7% more water vapor to the global atmosphere. So we warm the climate up, the atmosphere, the troposphere, and that adds more moisture. This is the precipitation trends from, if you put it all together, from 1895 to 2020. Note Vermont. So that's the overall trends, and they're up with some loss of precipitation across the Intermountain West. And the deal is, we're not seeing a lesser amount of, in other words, consistent drought. There are consistent droughts going on, but we're not seeing the extreme as we are seeing the higher trends east of, let's say, east of the Rockies, for example. Seasonally and then annually, we are also warmer and hotter in the eastern U.S. and wetter conditions in the eastern U.S., I should say. And then in the western U.S., it's obviously turning drier. So we have these kind of two things simultaneously, and this is what the climate models predicted. Warming in the winter changes up precipitation type here in the northern states like the Northeast and Great Lakes. Extra water vapor and an overheating planet is notable, which exacerbates the hydrological cycle. This is our daily surface air temperatures. Now, note the dark brown line there. That is 2024. And you can see that where we should be, let's say if we weren't warming consistently, we should be somewhere in those dashed black lines there. And you can see that this data, there's just tons and tons of years that have contributed there to look at. But note that we're warming, and the sort of lighter tan line there is 2023. Now, interestingly, if you note roughly about May of last year, 2023, the temperature went to record levels. It was about May, June, I think it was. And we started setting new records. And a lot of climate scientists their jaws were on the floor going, what is going on here? And the theory is that's when that extra warming of the oceans with the sulfur dioxide was now lacking. They reduced it 80%, and that was masking what was already there. So those temperatures shot up, and they're still running pretty high. And the good thing to note is that the temperature trends for 2024, because of La Nina, because we have the cooler phase now, is starting to cool down just a little bit. But we're still running a big-time fever across the planet, of course. Okay, so interestingly, about 7% of global warming from the sun, the energy, goes into the oceans. It's only the leftovers of that, 5%, 3%, 4% go into the atmosphere. So we heat the oceans up, and then that eventually heats up the atmosphere. That's how it works. So it's very important to look at daily sea surface temperatures. And what you can see there is the same kind of, it follows the same order as what we were looking at in terms of temperatures. The sea surface temperature anomalies are running real hot, and you can see that just how record-setting they were back in January, February, March, April, May, and we started getting close to the 2023 levels in June, July, this summer, and then we're starting to see that a little bit lower, and that is the effects of La Nina on the world scale. So largely the oceans warm fastest, warming like mad, setting records. And with the natural variation of El Nino in 2023, this boosted that temperature anomaly of the oceans. Any flows coming off the extra warm oceans has ramifications into the continental interior sections, such as us here in New England, the Northeast U.S. So consequently, basically for example, there's a big connection in our local winter storms where those sort of marginally warm temperatures, but cold enough for snow, produce that very heavy wet snow and power outages, not to mention the transition storms of snow to sleet to freezing rain and ice, which I'm expecting to see a lot of that later on this winter. We will have a winter, by the way, but it's not going to be the winters of old, in that sense. Arctic sea ice, you can see where we are here. We had the yellow dot there as the, I think we're running, there we go. Yeah, so we're getting that 20, that shows you where we are right now in terms of Arctic sea ice, which has been melting, and of course the warming of the ocean causes extra melting, the warming of the air causes extra melting and whatnot. There's a direct relationship of the loss of sea ice, especially in the Barents and Kara seas off of Scandinavia, to a weakening polar vortex. And that weakening polar vortex is going to be a player later on this winter, but it's kind of forcing our winters to be more backloaded here in the New England area. So it kind of comes in very, very slow, kind of that's what we're starting to see here. And this has been something that's been starting to be documented very well. Now, the ocean warming thus melts the ice that then allows the blocking areas of higher pressure to form over the Arctic. And the same thing takes place basically over the Antarctic, but we're concentrating for us here in Vermont, we're going to concentrate on the Arctic for a second. And these blocking areas of higher pressure reconfigure the jet stream and thus allow extra cold air into the mid-latitudes. So even as our winters warm and the Earth's temperature is warming, the atmosphere is warming, the oceans are warming, we're still going to get these oddball displacements of cold, cold Arctic air once in a while. It's really hard to figure out when that's actually going to happen. It's not very well modeled, but about two weeks, sometimes 2 weeks to about a month, you do get this sort of sudden stratospheric warming event. Is kind of very complex, and that produces kind of a weakening of the polar vortex, which then allows the cold air to come into our latitude in the mid-latitudes. And that's basically what we're going to see later on this winter. So we will have a stretch of very cold air at some point with this La Nina setup. Antarctic sea ice, during the 2000s and 2010s, the Antarctic sea ice volume was holding fairly steady, and then all of a sudden, boom, it's like everything caught up in the southern hemisphere. But overall warming the oceans more recently have caused big losses in sea ice around the continent of Antarctica. And this is where there's a little bit more writing, and again, I borrowed these slides from Sunny, which is a great name for a meteorologist, I think. I used to know a guy named Don Gales, It seems like I'm a hill, so I don't know. But actually, I'm Alex Jones. No, just kidding. All right. So an overheating planet reaches very far. If you're wondering why your cell phone drops out, for example, more frequently on a hot summer day, well, it's the heat. Heat's increasing, not decreasing. In the western U.S., drought coupled with heat causes sinking where the ground, the sinking of the ground because of aquifers are being pulled up with so much water in our major cities. You think of like Las Vegas and Phoenix and other places. And what's happening is interesting is that there's a connection now that's due to climate change. We're having more droughts out west. The aquifers are being drained, and due to humanity and whatnot. So the new climate connection reaches super far, even causes what we call subsidence earthquakes. So yes, earthquakes now because of climate change. So yeah, that's right. Earthquakes, and not only in the West. You're noticing they're starting to happen in southern parts of New England due to subsidence, due to aquifer water tables falling and whatnot. So this is something that's fairly significant and something to keep an eye on in the future. Yes, that's, if you think about, earthquakes are a problem. We don't really see them. We have a couple pretty active faults up in places like over toward Ottawa, Ontario, and a little bit in Quebec, and most of these are our big earthquakes we experience in Vermont. That's where most of them happen. And, we're a little bit distant to the south of that, so we're not too bad. But, stay tuned with climate change. You don't know, really. But the other thing that's really bad with the drought and the fact that we haven't had it, we're kind of in one of these systems right now where we're having very dry conditions, a super dry fall. Well, water levels of rivers lower. This shuts down generation, and it's a real problem a future problem for, say, nuclear energy, where you're getting, the problems where they can't take the control rods. There's nothing to cool the control rods. So this is a real problem here. Next slide. Too hot to op. So extended drought or dry spells are created by heat domes. We have these big, sprawling areas of higher pressure in the summer primarily. And under stagnant high-pressure systems, the pollution builds up. It gets progressively hotter each day. The temperature inverts aloft and stabilizes the weather regime and dries out the atmosphere. These cause extra episodes of sunny, hazy, and smoky days, sometimes endlessly. The effects are wide-ranging, from higher rates of skin cancer because of this to a myriad of other health risks and wear and tear, of course, on machinery. Machinery does not like heat. In fact, computers do not like heat. So this is a problem of the future. Fire weather. Not a huge issue for us except, well, most recently it's starting to become a problem. So the cycle usually goes drought, heat, and then to floods. But mark my words, Western wildfire activity will no longer be just a thing for Western states. And as I was writing this and putting this together, the signal was showing up in the east, now mostly to our south, New Jersey into the southeastern states. So when I wrote this, there were no wildfires yet, and all of a sudden we heard about them in New Jersey and then into New York City, as there was recently. So they're kind of creeping into the picture, and of course we have a very dry fall because of that, kind of related to that, I should say. Since 1980, at least 30 droughts have taken place. Billion-dollar climate disasters are stressing the federal system. Costs totaling $309.4 billion up through a couple years ago have been notable. And we haven't even added the last couple of years to that. So climate change-induced drought was costing humanity in real dollars. And of course, food insecurity is a big problem with that. I will be covering a little bit more about droughts as it's related to Vermont here soon. With overall increased precipitation during droughty weather and dry conditions, pollen counts have been on the increase in the spring especially, and also in the late summer and fall. And note the observed projected pollen changes under climate change. Look at Vermont, southern Vermont there. It's a little bit of a hot spot. The areas in the blue are the areas where they've been seeing a decrease in pollen. But the areas around generally the Appalachians, the southern Appalachians, and then into New England have seen an increase. So drought and seismic activity, I was kind of mentioning that, a new wrinkle. Climate change has caused earthquakes. New data shows groundwater aquifers getting depleted. Earthquakes occur, but not just that. Amazingly, earthquakes of magnitude 5 and above have been correlated to occur during the dry stage, causing fault lines to further stress and reach tipping points, thus more drought-related earthquakes. And this is a very new kind of phenomena we're talking about now with climate change. It's just crazy. As larger complexes of more intense thunderstorms loom in our future, now most of these, of course, during the warm season and whatnot, we're expecting to see an increase in the coming years with giant hailstones during the warm season, especially east of the plain states, with a more easterly climatological shift taking place. An NCAR study shows a 5-fold increase of the eastern half of the country of wet microburst gust front straight line winds, well-developed squall lines, or derechos. A derecho is like a super squall line. And the thunderstorm not only produces flooding, giant hail, and straight line winds, but also meso-low spinning tornadic thunderstorms, or what we call supercells. As the west droughts up, the east gets more violent, storm violent. And at times it extends into other seasons. Here in the Northeast, one may have to include severe weather with large hail, damaging winds, intense lightning, and even in the winter months in New England. So we might start to see thunderstorms that extend, through the fall months and into December, even maybe January, February, under conditions in the future. This map shows a comparison of flash densities of lightning strikes. The takeaway here is the brown areas have seen a doubling of lightning strikes with more thunderstorms, but this data set is from 2015 through 2021 as compared to 2022, so it's a little bit of a short data set here. But the following 2 summers here in Vermont were more active than what you're seeing here, as you kind of see a little bit of that blue, kind of purple color there. That is a decrease, not an increase. In those lighter brown colors, that's an increase. And note Southern California, look at places like Arizona, the deserts, and then up in areas around Montana. Those brown areas are areas that have seen increased lightning strikes. And the trend here is that we're going to see those increases of lightning as well. The role of heat in storm growth, so convective available potential energy, or what we call CAPE, it's kind of a measurement of instability of the atmosphere, shown in those areas where higher moisture and heat combines to pop those powerful thunderstorms I'm talking about. Days that feature high CAPE and strong varying winds aloft, where that causes a twist in the atmosphere and up and down drafts, and these organize into supercell thunderstorms. Supercell storms produce the strongest winds, hail, and organize into tornadoes. More lightning is expected. In later years, rising freezing levels will lower the hail incidence as hailstones will melt on their way down. But this will be, way around the corner. So we'll get into a period here where we're probably going to see larger hail. Now, lightning frequency, as I mentioned, will increase, and protection from lightning will be a thing in our coming future. Over the last 20 years or so, about 83% of major outages were attributed to weather. Most outages were produced by the warm season severe weather storms, such as thunderstorms or whatnot. And then also we have our extreme winter weather, and that was about 22%. So we're seeing power outages and energy loss, and what you can see in that sort of middle area there, the number of power outages lasting more than 8 hours by county, and that's been from 2018 through 2021. You can see Vermont is in that. We've seen some in California and whatnot, and also from hurricanes, tropical cyclones in the south and whatnot. But of course, our power lines need to be resilient, and it's a big time battle. Having worked for Velco and watching the storms and how that affects. The average annual electric power interruptions, lower left-hand sign shows statistically, where New England states have been hit fairly hard. Places like West Virginia and Florida are the worst for outages. Note Vermont has caused attention with storms that produce power outages increasing in frequency. So if you look in the lower left-hand corner, you'll see Maine and Vermont and then West Virginia and Florida. We're seeing some of the worst power outages in the entire country in New England. Increases in 1 and 6 and 24-hour rainfall totals, well, I think Montpelier knows a little bit about that. What Vermonters have noticed is the high water and flash flooding 2 years in a row. The blue areas show here on this map in the center there, show huge increases in the rainfall and the quickening flow of the hydrological cycle. The rates of ocean evaporation and overheated climate, evapotranspiration leading to extra precipitation, all of this has increased significantly. Water has been moving more quickly through the various stages. We're also seeing hotter and more, as conditions get hotter, of course, again, for every 1 degree Celsius rise in temperature, we're seeing that 7% extra water vapor, and that's interacting, and that's what's causing a lot of our big, heavy rainfalls. Historic tropical activity in the northeastern states through 2023. You can see there's quite a few tracks that move through New England. This is nothing unusual, but New England region has been no stranger to tropical cyclone activity. As oceans warm, especially along the east coast, tropical cyclones tracking up the coast will keep their intensity longer and then track further north and crossing further inland. Think Helene, which is what happened in western North Carolina, and also what happened with Irene as it rammed in and went up into Vermont and caused that flooding. So at some point we could see one of these Helene-type storms here in Vermont, keeping that in mind, and everybody knows what happened with that. By 2100, only a little over half of the Northeast will see accumulated snow in the winter. Very sad. Very, very sad. Winter temperatures warm fastest, then say summer. More rain, lesser snow. Now in the warm season, summertime, in 25 years, the number of hot days will increase from 10, as they are now, to 50 days a year in Vermont. Sea level rise will also promote climate migration. All these things are trending. So in Vermont, I'm going to kind of explain this one a little bit, but in the Vermont map that you see there, that shows where the tornadoes have been documented to occur. And notice there's a kind of a cluster up in the Champlain Valley area, a little bit east of the Greens and like areas around Craftsbury, up in that area, Orleans, Lamoille County. And then locally, there's another little hot spot. It's kind of a mini hot spot in Washington, Williamstown region. But also in southern Vermont, that area around Mount Ascutney, kind of west of Claremont there, back into Bennington County, those areas have seen our tornadoes. Otherwise, not something we normally see here in the Montpelier area, but maybe we will soon because we're getting those conditions more often during the summertime and maybe into the spring as well as into the fall. Eye-opening. Vermont now ranks second in the lower 48 overall for storm risk. Let me repeat that again. Our state, the Green Mountain State, ranks second overall in the lower 48. It's 38th for heat risk, 41st for fire, as you might expect. We don't see a lot of fire activity around here. And then it's 45th for long-term drought risk. All were trending up more rapidly. Top cities in Vermont with overall storm risk was Bennington. The lowest overall risk was Montpelier in terms of storm trend. But everything continues to rise gradually, right? Now for heat, it was Brattleboro having the highest risk. St. Albans, Vermont, the lowest risk. Fire, which is overall very low, Montpelier ranks highest, and Burlington lowest. We kind of know why, Champlain Valley, trees and whatnot. Now for drought, Brattleboro was the highest and Newport the lowest. For flood, Montpelier the highest risk, of course, because we have a confluence of many rivers, and Burlington was the lowest for flood. And 3/4 of a century, our summers will be the equivalent of experiencing a summer more like North Miami. And so we're talking 75 years out, 2100, but that's fairly significant. That's a big, big rise, and of course a very different situation than what we have right now and have had. What else is changing? Well, the lower left shows the increases in tick-carrying Lyme disease from more southerly locations as the climate warms. We're seeing less cold spells that make for a hostile environment for ticks. So ticks love warm winters. We're probably going to have a warm winter. The bigger panel on the right shows tornadoes in their tracks, as we were talking earlier. Tornado climatology, hotspots, again, the Champlain Valley, those southerly locations. And that's interacting with the Lake Champlain lake breeze that develops. It produces like a little convergence zone, and cumulus pops along that convergence zone, and sometimes they take off and they have enough little bit of a veering wind to cause a little spin up of a tornado. So on very high Cape days, we'll see a higher incidence of brief spin-up tornadoes. There are also many tornado alleys in New England, especially in eastern New York, Connecticut, Massachusetts, southern New Hampshire, and into southern and western Maine. So humans' ability to adapt to an ever-increasingly hotter planet has consequences. The ecosystems for wildlife habitat will take a huge hit, and it's going to be, problematic for our wildlife. And the write-up here, you can kind of read it for yourself, but it'll affect fish, for example, trout and whatnot, various other flora and fauna. Just as we get hot and just as the climate change for us and the warmth, it's really going to affect wildlife around us, our flora and fauna. So in a paper published by the Proceedings of the National Academy of Sciences, this is where the best niches for humanity have been in our past history, in that sort of greener area where you kind of note areas around California, Central Valley, Mexico, and whatnot. So those green areas shown here were most favored for humans on several levels. This green area has begun to shift more into the southern portion of Canada as the world warms, as one might expect. As the climate warms, we're seeing that northward change. 30% of Americans cite climate change as a motivator to move in 2024. So far, fire has been the main mover of climate refugees in the western U.S., but don't think after 2 or 3 or 4 floods in Vermont and elsewhere, everyone will stay put. This summer has seen more fires, more heat, more storms, all of it making life increasingly untenable in larger areas of the nation. Already droughts regularly threaten food crops across the West, while destructive floods inundate towns and fields from the Dakotas to Maryland to Maine. Welcome to Vermont. So 318 million have been forced to move by a harsh changing climate of floods and droughts, windstorms. 13 million residents of coastal areas will be displaced by 2100 just due to the sea level rise alone. Heat waves will drive people northward. Duluth and Buffalo will become climate havens. Extreme weather events and conflicts are the top 2 drivers across the world already today. One example is in Syria, where climate-induced persistent drought and then migration and conflict to the north that followed. And of course, this affects the politics of immigration. And the trends kind of sometimes set the stage. You get climate migration that then sets the stage for political upheaval, if you will. Projected counties of the U.S. that will eventually be severely overheated. We know where those are, the desert Southwest especially. The Great Lakes region in the northeast of the United States will become more attractive to climate migration. And Phoenix, Maricopa County, just kind of an idea, then they could see almost 6 months a year above 95 degrees. And it's really problematical because if the air conditioning, let's say the power goes out and they don't have solar, for example, they don't have a backup system, that's fatality time, that's death. And typically it's the super young people and generally older people that are affected by that. Climate damage as a percentage of GDP. Interesting to note that we are on the good side, that is, the damage in the Northeast, as it is so far right now, has been negligent and is not a problem. But note those areas in southern coastal areas, and then note Florida. Also note the Colorado River out west, Phoenix, Tucson, those particular areas. They're getting hit with climate damage as a percent of GDP. My sister lives out in near Phoenix, and it got so hot last year that the saguaro cactuses fell over. Yeah, saguaro cactuses have not seen the temperatures they have seen most recently. So things are changing. Again, we're in the Anthropocene. Climate migration example, the horrible Paradise wildfire saw residents flee around the country, and some of those residents, they even moved to Vermont. So get ready, planning commissions, as climate migration will be a real thing. We are kind of a little bit more of a haven, obviously. We have our own issues with floods and whatnot, but we're looking very, very, very attractive to the rest of the country. Coastal sea level rise will push out residences of low and coastal areas. they'll reestablish inland. It appears that central and southern Vermont will see the most of these recipients here that get affected by sea level rise in our near future. And unfortunately, those of us snow lovers will see less and less snow, but not linearly. Now, some years we'll still have some really big snowfalls, but they'll become fewer. This is our winter projection for this winter. Not looking too good in the snow department, is it? So we'll have snowfall starting next week, in fact, coating higher terrain, but compared to past winters, do not expect nearly so much snow early in the season. Winters of the future will be more backloaded and associated with those cold Arctic outbreaks, a complex disruption of the polar vortex and displacement of colder temperatures and anomalies look more certain when that takes place. But this is not going to be an average winter. I think our average winters are definitely going to be more kind of variable, ups and downs, and some parts of winter will be no winter at all, other parts will be like the old days. So I expect that at some point we will have skiable snows and cross-country skiing and snowshoeing, but it may not be for a very long time. And that concludes my presentation. Thank you very much.
We're going to just take like 3 questions from the audience, okay?
Yep. So we're going to do 3 questions. Anybody?
And I'm going to write them down so we can share them with everybody. Anybody got a question? Raise your hand.
Earthquakes and stuff, and the cyclones, the tornadoes rather. What's the trend on the map was, if I got it right, the map was the tornadoes that we've had. How has the trend over the past?
Okay, can you repeat the question?
Yes. So the question is, how is looking at tornadoes, which are associated with supercell thunderstorms, what is the trends of the tornadoes? The trends of the tornadoes are a shift east, a little bit east of the plains, a little more like the eastern plains, into the rest of the, say, Mississippi Valley, Ohio Valley, and yes, heading more northeasterly into Vermont and the northeast U.S. So we will see an increase in tornadic thunderstorm activity, or at least the conditions that support tornadoes now, you know.
Historically seen over the last, whatever, 20, 30, 50 years, an increasing number of...
Yes, and you know what the most they've seen? Quebec, southern Canada, Quebec. As the climate warms, we'll have the conditions that extra CAPE, that convective available potential energy, will pop bigger thunderstorms. You have a stronger jet stream in the north. All of that combination spins up tornadoes. And they're seeing more incidences of tornadoes, especially in Quebec.
So I have another question for you.
Yes.
You said Vermont was second in storm activity. What kinds of storms?
Okay, good question, because that was a question I had
Can you
as well.
repeat it?
So Vermont ranks number 2 now in the country, New Hampshire number 1, by the way. Yeah, we're in the zone here, okay? So what kind of storms are we talking about? We're talking about storms that produce damage. So that can be a windstorm, it could be a heavy rainstorm without thunder, it could be a thunderstorm, it could be any storm that causes damage. Those are the higher incidences, and that's why Vermont ranks currently right now second. Now, next year, those stats will come out, and I wouldn't be surprised if Florida's number 1. So these will vary as time goes on.
Roger, how about the earthquakes? What conditions have to happen for there to be earthquakes of your time?
Let's say southern New England, or what I did notice is that the Connecticut River Valley areas, more into southern Vermont, like around Windsor County, Windham County, they're seeing drier conditions. The droughts are a little stronger. The aquifers the water tables below are draining, and that's causing more of these subsidence earthquakes. And some of them you can't feel, but they're noticing there's a correlation to, again, drought and dry weather that are causing fault lines to stress and then shake.
Okay, we got another one. What's going to happen to the maple industry?
Oh, good question.
Repeat that?
Okay, the question is, what is going to happen to the maple industry? I can't predict exactly what's going to happen to the industry because we're adding more, it seems that the maple industry is taking off. But I can tell you that the conditions that support temperatures that go below 32 degrees in the spring, and then you really have to have that freeze thaw going on in March and April, and sometimes in February, sometimes in January and December. We've had people boiling in last year, I believe it was, in December or January. But I'll get to that in a second. But what's interesting is when we have this real dry condition here in the fall, it sucks. It makes it much worse for boiling sap and making high-quality maple syrup, maple sugar next spring. So we'll see what happens. That is the findings from the Procter Maple research people, that dry falls and dry summers are bad news for the following year's crop.
I'm going to step in for a second.
Yep.
So we know that you all have questions, or they're bubbling up in your heads. Roger is going to stick around for our little informal gathering downstairs. I know not everybody can stay, but you will be able to get Roger's slides in a follow-up email. So I encourage everyone, I'm sorry that we're behind time, but we have a few things we want to cover before we let you all roar out of here. And apologize for the lack of time with questions. So Rebecca's going to just take us out.
Hey everyone, I'm Rebecca. I'm a community organizer with 350 Vermont, and I hope if folks are able, they'll stick around for just a little longer, because we just heard some pretty heartbreaking things. And I don't want to peddle a false sense of hope, but I want to give folks some options and some ideas of what we might be able to do together. So if you'll bear with me a moment, I'm just going to pull up our next set of slides. So, I don't know why they're not showing up on there, but on the screen. Oliver's going to help us out for a minute while I talk to you all for a minute. Oh, thank you. Is this better in terms of sound? Can people hear me okay? Okay, sorry for the I know that was, Roger, that was amazing, and so appreciate all of your knowledge. And I know I'm feeling a lot of things, and I just want to give us a moment to think about and feel what we might be feeling. Is anyone feeling grief about what Roger just shared? And feel free to just raise your hands. What about sadness? Yeah. How about despair? Is anyone not, maybe some people are not sure what to feel? Is anyone feeling numb? So, on top of all our feelings around climate that are here in the room right now, I think we all are also painfully aware that we're likely moving into a time of deep heartbreak on many levels. And at 350 Vermont, we've been thinking a lot about what that means for our role in the climate justice movement and how we can move together to meet this time. We're going to talk about some things we might be able to do, but I'd invite everyone first to take maybe the deepest breath you've taken all day and let it out. And I invite you to look around the room, maybe look next to you, or behind you, or in front of you. I counted 127 people here tonight. And I invite folks to consider the social movements that came before us and the powerful change that organized people can make. I know we don't have a lot of time tonight, but I know we also don't really have time to do something meaningful for our climate with what Roger shared, but that doesn't mean that we can't adapt and that we can't be there for each other and that we can't try our best to do what we can do. I'm curious if anyone, does anyone here know who Erica Chenoweth is? No? Okay. So if you had to guess how much percentage of a population had to show up and participate and ask for change in the history of social movements, do people think it's more than 20% of people that need to show up and say, like, we need change? Who thinks it's more than 20? Who thinks it's more than 10? So, Erica Chenoweth looked at social movements across history, and she found that for every single movement, if 3.5% of the population was brought along and was actively engaged, those movements never failed to bring change. So I think the population of Montpelier is about 8,000. 3.5% of that is 280 people. That means that at the beginning of this event, if every single person in this room brought along 2 friends and worked toward creating change in Montpelier, that would meet that 3.5% threshold. So I just want to share a little bit about our theory of change at 350 Vermont. How do we think about creating change? We work towards specific time-bound goals that move us closer to our vision of the world we want to see. Each action or tactic builds our people power and moves us toward our goal. And each goal builds our people power for the next campaign. When we take collective action in our communities, we build our power to take on something bigger and make bigger change. But we build something else too. And this is what I think about when I'm reminded of just how dire our situation is. When we take local action in a strategic way, certainly we're building our power for something bigger, but we're also building our power to be there for one another. Our work in the Montpelier Node, which is our local 350 Vermont group here in Montpelier in central Vermont, and at 350 Vermont at large, is also part of something bigger. We're going to talk about some really local actions we can consider taking, but there are groups, 350 Vermont groups, and many other organizations and individuals who are also having these conversations. There are people all over the state, organizations all over this region, and also all over the country that we're connected with and that are also doing this work. So, in this time, how do we figure out what to do? And we've been asking ourselves this question a lot since the beginning of the month and the elections, and reconsidering what our plans for 2025 look like. We're engaging in a process like this. We're going all around the state, hearing from people and hearing what they feel called to do. And we're going to come back together at the beginning of next month on Zoom, everybody's favorite, and think about what next steps we will take together. And everyone will be here is invited to that meeting, and stay tuned about how to plug into that. And then based on that, we have a Just Transition campaign team, which is composed of volunteers, and they will make recommendations for our 2025 goals. So that's how we're planning as a grassroots movement to decide what we want to work on together in this coming year. I want to share just a little bit about what we're thinking, and then everyone will have a chance to fill out, to give us some feedback that we'll collect to hear what folks in this room feel called to do. Right now, we believe we need to bring people together who have been pitted against each other to build resilience, community, a shared vision, and collective power for the future. We want to continue to grow our movement. I'd love for people to raise their hands if any of these resonate you. Like, who thinks we should continue to grow our movement? Yeah, awesome. Each of you, next time, bring another person and we will grow our movement. How about creating safety and resilience in our communities? I know that's really important to me. How about making this energy transition affordable and accessible to all of us? Yeah. How about embracing alternatives to burning fuels and carbon-emitting sources, and also conservation and weatherization? Awesome. In 2025, we could have local projects all over the state that both reduce greenhouse gas emissions, build community and resilience, create a larger tent, and build our movement to tip the balance of power to create the world we want. This is a whole bunch of ideas that some of these we've been working on for quite a while, some are new. This isn't everything that we could do. Creating networks of support and taking care of one another, bringing everyone along, adaptation, reducing our use, electrifying and sourcing our electricity responsibility, and stop burning things, stop putting emissions into the air. I want to talk about this last one for just a moment, and then I'll elaborate on a couple of the other ones. So right now in Vermont, we don't have any natural gas plants that generate the electricity we use here, even though those are located in other states and other people's backyards. But we do have McNeil and Rygate, which are biomass plants that burn wood to generate electricity. And even though they sound green because it's wood, they actually put a lot of greenhouse gas emissions into our atmosphere and are really negative for the health of those who live in communities where they're located. So I'm just going to highlight a few of these. I want to start with create networks of support. So how will, as we think about the past couple of weeks and what happened in the election, we're asking ourselves, how will our immigrant neighbors be impacted? And how do we organize to support them? How do we support rural, poor communities impacted by flooding and neglected in recovery? How do we support union members? How do we protect our access to health care? Who else needs our support? And how do we take care of one another? What does this have to do with the climate? So climate justice is a training that is a whole training that we have, but I'm gonna let Audre Lorde say it simply for now. There's no such thing as a single issue struggle because we do not live single issue lives. I'm going to skip a few of these just because we're short on time, but I'm going to share these slides with you all, or anyone who signs up, so you'll get them afterwards in addition to Roger's slides. One thing I want to highlight is building thermal energy networks as a local action we're considering. This is one tool in our toolbox for reducing our use, and it's a way to share existing waste heat to heat or cool buildings in a network connected by water-filled pipes in a closed-loop system that can also include ground source heat pumps. And this is an excellent community project. My tiny energy committee in Northfield, which has 3 people, is working on this, and people are really excited about it. And this is a doable, bite-sized thing that people can bring to their towns and their energy committees. Rental weatherization. So many of our rental units aren't properly weatherized. And one of the first steps for making this happen is requiring there to be a rental registry in Vermont. And our friends at Rights and Democracy are working really hard on this. And so if you're interested in that, there will be a place at the end to indicate that you're interested, and we'll connect you with Rights and Democracy. Weatherization barn raisings. So this is thinking about how can we help our neighbors and each other weatherize our homes to the best of our ability. This could look like community or neighborhood weatherization parties, or button-up work parties, and probably lots of other ideas. YIMBY, this is kind of a silly thing to say, but this is about sourcing our electricity responsibly. So people have probably heard of NIMBY, meaning not in my backyard. One of the things we're considering that's on the table is yes, in my backyard. So developing understanding and will to have solar in our communities so that we can source our electricity responsible. There are a lot of ways our communities can lead. We can create networks of support. We can consider how we will adapt, and I know in central Vermont we are painfully aware and doing this. We can explore the feasibility of thermal energy networks, plan for siting solar in our communities, keep biofuels and hydrogen out of our local energy plans, organize weatherization barn raisings, and share information about energy efficiency and other renewable resources for our homes. So how can you get involved? So some of you had like a paper on your seat when you came in, and it says Next Steps form at the top. Over double the amount of people who RSVP'd came, which is amazing, but it also means we don't have Next Steps forms for everyone. So if you have a Next Steps form, in a moment we'll ask you to fill it out. If you don't have a Next Steps form, you likely have an index card nearby you. If you don't have a Next Step form or an index card and need something to write on or something to write with, could you raise your hand, because we want to make sure you are able to give us some feedback. Does everyone have something to write on and with? Okay, excellent. So folks with Next Steps forms, please fill those out. If you have a note card, if you don't have a form and just have a note card, if you could please put your name and your contact information and what resonates with you, what you might feel called to do. And then we will collect those all at the end and report back to folks on next steps. Two other opportunities to get involved is coming to our Montpelier Node meeting in the new year. Folks who are in the Montpelier Node, I wonder if you would all mind standing up for just a moment. I don't want to embarrass you, but if you're in the Montpelier Node, will you stand up and raise your hand and wave it around? Yeah, please clap for them. So these folks organized this entire event. They did all the outreach and the logistics, and they're a small but mighty crew, and joining their group is a great way to get involved. They'll be choosing their next project in the next month or two, and we'll certainly need more hands. And then also coming to the December 2nd statewide meeting, we'd love to see folks at. If you just have a note card, by the way, please indicate if you want to either join the node or come to that meeting so we can make sure to get the information to you how to do that. All right, we're going to give people like 3 minutes to fill those out, and then we're going to officially close, but then there'll be ample time downstairs with food and informal talking, and you can then take some extra time to fill out your forms. And I would, if you want to stay, I would say fill out your forms and don't leave yet, because there is a special treat before we leave this chapel, and I think people might want to stick around for it.
It's not whether everybody just drift away.
I have a little bit of an announcement as well to make, just personal. I'm getting a lot of people asking me when I'm going to go back on the radio, December 2nd.
All right, this just in, because I don't want folks to miss out on this. We were going to wait till people were finished filling out their forms, but we're going to close with a song right now. So if you want to sing with Casey and Danya, please. They're gonna lead us in a brief song.
You're going to put the words up. You're going to put the words up. Oh, yeah. Yeah, okay. This is a song written by Melanie DeBoer, who's an activist in Oakland, and she wrote it the day after the 2016 election. It's very simple, and we can all sing it together.
And if you're getting tired of just sitting there, please stand up,
Yeah.
move around. I'm going to be singing the main section several times. call and response card.
You gotta put one foot in front of the other and lead with love. Put one foot in front of the other and lead with love. You gotta put one foot in front of the other and lead with love. Put one foot in front of the other and lead with love. You gotta put one foot in front of the other and lead with love. Put one foot in front of the other and lead with love. Don't give up hope. Don't give up hope. You're not alone. You're not alone. Don't you give up. Don't you give up. Keep moving on. Keep moving on. You gotta put one foot in front of the other and lead with love. Put one foot in front of the other and lead with love. You gotta put one foot in front of the other and lead with love. Put one foot in front of the other and lead with love. Lift up your eyes. Don't you despair. Look up ahead. The path is there. You gotta put one foot in front of the other and lead with love. Put one foot in front of the other and lead with love. You gotta put one foot in front of the other and lead with love. Put one foot in front of the other and lead with love. I know you're scared. And I'm scared too. But here I am. Right next to you. Right next to you. You gotta put one foot in front of the other and lead with love. Put one foot in front of the other and lead with love. You gotta put one foot in front of the other and lead with love. Put one foot in front of the other and lead with love. And lead with love.
So please join us downstairs. There's refreshments. Roger's going to be there. You can get a chance to talk to him, talk to us. Thank you all so much for coming. You will be getting a follow-up if you signed up with us that will include all of Roger's slides as well as our slides and a link to the recording. Please share all of these things widely.